Welcome everyone. Mike Vave here. Today I have a new study to go through with you guys. It's a caloric restriction study in rhesus monkeys that I discussed earlier when I did the caloric restriction study in rats. The title of the study is called Caloric Restriction Improves Health and Survival of Rhesus Monkeys. I'll put the actual paper in the description here so you guys can check it out, and it is referenced throughout the slides. So we're going to jump in, and basically what we're going to look at today is there was two major caloric restriction studies done with primates longer term, particularly rhesus monkeys. There's some pretty significant differences in those studies, and then also the results. So we're going to kind of this paper at least compares both of those studies. So we're going to look at their comparisons, and we're going to look at the diet that these monkeys had, and then the subsequent effect on health markers that we'll see down the line. So it's quite interesting. It kind of provides a context for some of the caloric restriction research that hasn't really been fully discussed. When people discuss it, they just say, cutting calories by 40% or 30% leads to these drastic increases in lifespan, but there's no concept of, okay, so what are we comparing these different animal groups to, the caloric restricted versus the control? What's the control group look like? And the other question is, what are the actual diets that are being provided? So let's jump in. So the two studies that I mentioned, we'll stay here. The two quality independent studies of rhesus monkeys have assessed caloric restriction in primates. The National Institutes on Aging study, which involved 121 monkeys. This one reported no significant impact of caloric restriction on survival, although there were health improvements that didn't necessarily reach statistical significance, but were close. The second study was the University of Wisconsin-Madison study, which involved 76 monkeys, and then it did report a statistically significant benefit of caloric restriction, and also included significant improvements in health and age-related survival and all-cause survival. So the NIA study didn't find a benefit of caloric restriction, whereas the Wisconsin study did indeed find a benefit of caloric restriction. And we're going to get into why there is a difference between these two studies, and from like a dietary perspective. So we'll see that in just a few minutes. Now, the first thing we're going to get into is what was the feeding structure. So in terms of how were the control group, how much calories was the control group given versus how many calories was the experimental group given. The experimental group in this case was the group that was calorically restricted. So with the NIA feeding structure, what they say here is, with the launch of NIA rhesus monkey study in 1987, the implementation of caloric restriction was such that the control monkeys were not free-fed. So in this study, this is very important. The control group was not fed ad libitum, or fed as much as they wanted to eat. There was a control placed on these monkeys. So what they say, the continued food allotments were determined in accordance with data published by the National Research Council to provide approximate ad libitum intake based on their age and body weight for maturing control monkeys without overfeeding. Rations were increased to maintain growth and development until full stature was attained. Caloric restricted monkeys received 30% less food than height, age, and sex max control monkeys. The intervention was initiated as young onset and old onset group of males, and young adult and old onset groups of females. So what they're saying here is they basically looked in a research database to determine what the approximate amount for ad libitum intake was for these control monkeys without necessarily overfeeding them. So it was without having them gain massive amounts of weight or overeating a significant amount of calories or anything along those lines, so that the control group was controlled in their intake to some extent. And then the calorically restricted group received 30% less food than similar monkeys in height, age, and sex. So you have two groups. You have a control group not fed ad libitum, but fed at an approximate value and avoiding of excessive overfeeding. And then you had the experimental group, which was a calorically restricted group. They just received 30% less food than the monkeys matched for height, age, and sex. Then it gets a little bit confusing, and we'll go through this when we get a little bit more into the study. But the different groups for the male and female rhesus monkeys in the NIA study were further split between young and juvenile groups and then old onset and adult groups. And the reason they did this is because the monkeys that they started with caloric restriction came at all different types of ages. So they didn't all start when they were young. They started at different points. And so the researchers broke down the data based on these different age groups that the monkeys had been stratified into. The UW structure, so they say here, launched in 1989. The UW study initiated caloric restricted diet in adult animals only after full stature was achieved, about 8 years of age for rhesus monkeys. Food was provided at levels approximating ad libitum to control animals. To accommodate heterogeneity in feeding behaviors within the cohort, the ad libitum reference for each individual was established using baseline food intake measured over 3 to 6 months, and caloric restriction was implemented on a per individual basis. So essentially, they looked at the food intake of the monkeys over a 3 to 6 months period. And again, they're only using fully grown monkeys here, so that were at least 8 years of age and had reached full stature. And then essentially they were taking that average 3 to 6 months intake, and that was the ad libitum reference value for those monkeys. And then the calorically restricted monkeys, once they looked at their 3 to 6 months average intake, they took about 30% off of that for the caloric restricted group. So in UW, you had groups that were fed ad libitum, and then for the control groups, and it was based on an average of their ad libitum intake over 3 to 6 months. And then the control group or the experimental group, which was the calorically restricted group, had their calories cut by about 30% after determining that baseline ad libitum intake. So, differences in feeding structure of the different monkeys, or in between the different studies, looking at food source. So this is going to be really important when we get into this, because the NIA feeding structure and the UW feeding structure in terms of foods that were fed were drastically different, although still both of them sucked. So let's just put it frankly, the feeding structure for both of them was terrible. Neither of these diets would be considered healthy diets. And we'll also look at what a healthy diet is, or a normal diet is, for rhesus monkeys. So in the NIA feeding structure, a naturally sourced diet was employed at the NIA facility to ensure that micronutrients such as phytochemicals and trace minerals were provided, acknowledging that there is potential for seasonal variation. In the UW feeding structure, in contrast, a semi-purified diet was employed at UW to ensure that intake could be fully defined and consistent throughout the course of the study. So here we see the NIA diet. They were fed soybean and fish meal, wheat, corn, sucrose at 6.8% of the diet, soy, corn, fish oils, and then cellulose for fiber. Not really a great diet. And I think, and we'll talk about, let me finish with the UW, and then I guess we'll make some extensions here. The UW diet was lactalbumin, corn, sucrose at 45% of the diet, dextrin, corn oil, and cellulose. So even worse than the NIA diet. Significantly worse. So what we're seeing here is that with the NIA diet, first of all, with the NIA study, we didn't really find a benefit for caloric restriction, or at least it wasn't statistically significant. And I'm going to go through that data in just a bit. So, and their diet was, well, not a good diet overall. It was better than the UW diet by a lot. The other thing is the NIA monkeys in the control group weren't fed ad libitum, whereas the UW monkeys were fed ad libitum. So we have two things that could possibly be leading to the adjustment in the outcomes from these two studies. So the NIA, again, didn't find a benefit or statistically significant difference in longevity with the caloric restricted group compared to the control group, but their diet was way better than the UW diet, even though the diet still is pretty garbage. And then they also weren't feeding the control animals ad libitum. So this is quite important. And again, for anybody who's unaware, ad libitum means just as much as they wanted to eat. So essentially, in the NIA, you're comparing something a little bit different than what they were looking at in the UW. UW study was looking at a really crappy diet, 45% sucrose, and saying, hey, these monkeys that ate this 30% less of this terrible diet compared to this other group of monkeys who were able to eat as much as they wanted, had a survival benefit, which obviously isn't surprising. Whereas in the NIA study, you're saying we don't really see this massive survival benefit or this massive longevity effect. The diet between the monkeys was a little bit better, and one group was fed 30% less, while the other group was fed just enough so that they can like maintain normal weight and stature and not overeat excessively. So it's different structure, and I think that's why we're seeing this different outcome in the study's results. So as they continue, and we'll talk about this now, what was the macro breakdown of the study? So what we get here is, second, although diets at both locations had a similar caloric density, the relative macronutrient composition of the diet was not equivalent. Compared to the UW diet, the NIA diet was lower in fat, higher in protein, and higher in fiber. Finally, the nutrient contents of the diet was also different. At both locations, diets contained about 60% carbohydrates by weight, but sucrose comprised less than 7% of total calories at the NIA and 45% of total carbohydrates at UW. Diets at both locations were replete for vitamins that were provided at or above the recommended daily allowance. So what you're seeing at the NIA diet here is you have a higher protein content and you have a higher fiber content. It looks like up to almost twice as much at certain points. And then you also, the carbohydrate content that the monkeys are having on the NIA diet is coming from, I guess you could say, better, like more whole food sources. So soybean, fish meal, soybean and wheat and corn, instead of just pure sucrose. There's only 6.8% sucrose in the NIA diet versus this 45% in the UW diet. So basically, the NIA diet is a lot better than the UW diet from that perspective, and then also from the macro breakdown to some extent. The other thing you'll see here is that the vitamins in the NIA diet are significantly higher than the UW diet. So we're at 140% of the RDA in the NIA diet. In the UW diet, one of the groups, a calorically restricted group by weight, is at 130%, controls at 100%. So the UW study provided a better diet overall. Again, it's still a crap diet. We're looking at soybean and fish meal, and then wheat, corn, and sucrose, and then soy, corn, and fish oils, and cellulose. So the real study would be, what does caloric restriction look like in monkeys eating their normal diet, like a normal healthy diet, which we'll talk about in the next few slides, versus like monkeys eating their normal diet without being calorically restricted. Here it's saying, are monkeys surviving if they eat less of a crap diet? That's really the question that's being asked. And then comparing the two studies, it's, in one study, are monkeys living longer or having longer lifespans and less disease if they eat less of a crap diet compared to monkeys eating as much as they want of a crap diet? And then the other group is, are monkeys living longer eating a somewhat better diet than the NIA study is eating a better diet than the UW study, and then compared to monkeys who are eating just enough to maintain their weight, etc. So it's, the studies are separate, are created separately, and then the questions that they're asking aren't necessarily ideal. I mean, nobody would sit here and say, oh, look, these are great diets. Oh, the caloric restriction must have been super beneficial overall. So this is just a brief breakdown to some extent of components of the diet, the natural diet of rhesus monkeys. So the quote here from this paper is, they say, in less human influence areas, they, i.e. the rhesus monkeys, focus on fruits, flowers, leaves, seeds, gums, buds, clover, roots, bark, and then they supplement their food diet with termites, grasshopper, ants, beetles, and mushrooms, and they also eat bird eggs, shellfish, and fish. So in a normal rhesus monkey's diet, it's largely a plant-based diet of whole food plant sources that are quite fibrous, and then they have some insects, eggs, and fish or shellfish on board in smaller amounts. Compared to, if we go back here, soybean, fish meal, wheat, corn, sucrose, soy, corn, fish oils, and cellulose, or lactalbumin, corn, sucrose, dextrin, corn oil, and cellulose. So massively different diets. I wouldn't be surprised if monkeys eating like their natural diet matched for caloric and macro intake and vitamins and minerals, if these monkeys would outperform calorically restricted animals eating the crappier diets. And we'll even see between the differences between the NIA and the UW that even the NIA situation, there wasn't massive changes in certain markers compared with some of the UW monkeys. So the other thing that altered here a bit, not necessarily as important, but is something to bring up. At the NIA, the monkeys were fed, it's about feeding structure. So at the NIA, the monkeys were fed 2 meals at 6:30 and 1 o'clock each day. Any food remaining after the morning meal was removed after about 3 hours, and a low-calorie treat was provided, typically in the form of a small piece of fruit. The afternoon meal was not removed so that monkeys had access to food at night. So the monkeys were able to eat throughout the day if necessary. Whereas with the UW feeding structure, there's a little bit of a difference. So what they say is at UW, all monkeys were fed in the morning at 8, and any remaining food was removed at 4, when a treat of fresh fruit or vegetable, which was quickly and completely eaten, was provided. Food allotment for control animals was adjusted to ensure that there was always some uneaten food to be removed at the end of the day. In this way, UW animals were ad libitum fed during the day, but food deprived overnight. So the UW structure also had an overnight fast, whereas the NIA feeding structure didn't. Now, that could have, like having the overnight fast could have altered things a bit, possibly in benefit for the UW if you consider the fasting beneficial, and that could explain possibly some of the benefits in UW as well. But there also has been some contention about fasting recently, as like some of the fasting structures leading to worse hormonal profiles and body compositions in the long run in people who are lean and things along those lines. I don't think that necessarily applies here, but you could have seen some benefit in the UW, possibly in longevity, maybe because of some fasting, but I don't think that's the key point here. The bigger point would be more along the lines of the of looking at the different diets overall. So next thing we're going to get into now is the results of the study in terms of the survival estimates. So here we're going to look at the UW survival estimates. What they say here is in the UW adult onset study, the estimated survival of UW control animals was close to that of the average recorded for monkeys in captivity. Considering both males and females together, a statistically significant effect of caloric restriction in increasing survival was observed. The hazard ratio of 1.865 indicated that at any point in time, the control monkeys had almost twice the rate of death when compared to calorically restricted animals. The effect of sex on the response to caloric restriction was not statistically significant. Kaplan-Meier analysis showed that the median survival estimates were greater for calorically restricted animals for both males and females. So this table, the Kaplan-Meier analysis, or a Weibull median, KM is the Kaplan-Meier here. Those are all types of statistical tools that you can use to analyze the data here. So this is what they use to look at the survival estimates. And so what we see here is we have male and female monkeys in the UW study, and they're comparing the control group and the calorically restricted group in terms of the length of life. And what you're seeing here is with all of these statistics for males, the calorically restricted group lived longer on average, or they had a longer mean life than the control group. So 28 here versus 26, 26 versus 25, 27 versus 25. And then with the females, you're also seeing a significant difference as well. So here you're seeing on average, the caloric restricted monkeys reached here, I think, about 29 years versus 23.8 in the control. And then the median, or again, another average, so 25.7 versus 23.5. And then lastly, we have the mean age here of 27 versus 24.5 in the control. So overall, both the females and males in the UW study lived longer than the calorically restricted monkeys in the UW study lived longer than the controls. However, in the NIA study, we're going to see something a little bit different. So in the NIA study, what they say here, the Kaplan-Meier median estimated survival was not different between NIA control and calorically restricted animals for the juvenile adolescent onset groups of males or females. Although Cox proportional hazard regression indicated the difference in survival between juvenile and adolescent control and calorically restricted were not significant, calorically restricted monkeys reached 80% mortality before the control for both sexes. With 38% of the NIA juvenile adolescent cohort still alive, the survival curves are incomplete and the impact on the survival remains to be determined. However, the early mortality suggests that for some individuals, implementation of caloric restriction in the very young may convert a survival risk. For old onset caloric restriction, Kaplan-Meier estimated survival was not different between control and calorically restricted groups for either males or females, but survival estimates were higher than those of the juvenile adolescent monkeys and the UW controls. So, first things first, there was no statistically significant difference in survival between the NIA control monkeys and the calorically restricted monkeys. And in fact, in the juvenile adolescent monkeys for both males and females, the calorically restricted monkeys died way before the NIA monkeys, and some of the way before the control monkeys, and some of the control monkeys are still alive, whereas where I think most of the calorically restricted juvenile adolescent monkeys have died. So they couldn't completely put out the survival curves here because you still have some of the control monkeys still alive. The other thing that they're seeing is that in the old monkeys, for both males and females in the NIA study, there's not really a significant difference between the calorically restricted animals and the control animals overall. So what we're going to look at here is we're going to look at these median and mean values, comparing the ages or the ages of these different groups. So here we have for males in the NIA study, we have juvenile and adolescents, control versus calorically restricted. So the controls, their median according to this statistic was about 28.7 years, whereas the calorically restricted was 26.3 years. Over here with this different statistic, the mean came out to be about 26 years, whereas the calorically restricted mean age came out to be about 23.7. And then with the Weibull median, what we're seeing, the control group's age was about 29 on average, and then the calorically restricted was about 25 years. So in the juvenile and adolescents, the calorically restricted group, according to these statistics, all live significantly less than the control group monkeys. For males, we'll also see the same thing play out for females. And we can see here the control group 25 versus the calorically restricted group 22 years. The control group here 24 years versus 19 years for calorically restricted. And then for the control group 25 years versus 23 years calorically restricted. So what we can see from this is that caloric restriction, at least in rhesus monkeys for juvenile and adolescent, or starting caloric restriction in juvenile and adolescent age for these rhesus monkeys, actually decreased their survival overall. So probably not ideal to start caloric restriction before you're reached a full adult size or an adult age, particularly within the rhesus monkeys or within this primate group, which is in stark contrast to the rats or mice. And rats or mice, when they started caloric restriction younger, there's actually improved survival. So in these studies, what we're seeing is actually, at least for monkeys, you probably don't want to restrict their calories when they're very young. Now we'll look in the control groups, or we'll look in the older groups. So for the NIA study in the older groups, what you're seeing is with the Kaplan-Meier median, the control group lived on average about 34 years, 34.7, whereas the calorically restricted lived about 37 years. If we come to the Kaplan-Meier mean, you see they're both about 34 years. And then if you come to the Weibull median, you see one is 34 and the other is about 35 years. So there's not a statistically significant difference here. But it looks like the calorically restricted group did live a bit longer than the control group in the older monkeys. Now, again, the calorically restricted group is eating less of a garbage diet than the control group, and they're all matched for receiving 140% of their DRI of vitamins and minerals. So not surprising here. You're eating less of a crappy diet, but you're still maintaining nutrient repletion, or you're replete in your nutrients. With the females, what we're seeing is the control group had about 27 years on average, whereas the calorically restricted had about 27 years for the Kaplan-Meier median. With the Kaplan-Meier mean, the control group had about 28 years, and the calorically restricted group had about 26 years. And then for the Weibull median, you're seeing about 29 years for the control and 26 years for the calorically restricted. So what are we seeing here? It looks like in the females who started caloric restriction when they were older, there actually wasn't a benefit for the caloric restriction group over the control group. It looks like it was some of these statistics, the females actually lived on average or had a longer median age or an older median age than the calorically restricted animals, which is surprising. So in the NIA study, the benefit that we're seeing in terms of survival rate or age is seen mostly in the old males and less so in the old females or the juvenile adolescent males or females. And then again, in the old males, it's still cutting it pretty close and it wasn't statistically significant. So we're not seeing that survival benefit that we saw in the UW. And again, I think this comes down to how crap the diets were. And the NIA diet wasn't that bad, and they weren't comparing to ad libitum feeding, whereas in the UW, the diet was terrible, and they were comparing to ad libitum feeding. They were comparing caloric restriction to ad libitum. So now we're going to look at NIA versus UW survival estimates. And what we see here, there was a quote here, for both males and females, survival estimates for the NIA old onset cohort were comparable to or exceeded those for the UW caloric restricted. So what they're showing here is we're going to look at for females versus males in the NIA old. So in the NIA study, we're looking just at the old group, not the adolescent and juvenile group, because we already discussed that the adolescent and juvenile group didn't do well with caloric restriction. But if we look here in the NIA controls actually outlive the UW calorically restricted monkeys. So the control monkeys in the NIA studies are outperforming the UW monkeys in the old groups pretty consistently. So what we'll see here is the NIA old males versus the UW caloric restricted. So we see about 37, or I guess we'll do control. So about 34 years here versus 28 in the UW. 34 years here for NIA old monkeys versus 26 years for the calorically restricted UW monkeys, and then about 34 years here for the NIA old monkeys versus 27 years for the UW calorically restricted monkeys. So again, in male monkeys, the control monkeys in the NIA group who ate a better diet outlived the UW monkeys who were calorically restricted on a crappier diet. Just something interesting to point out. The females here, what we look at, if we take the NIA old females, their controls, and in the median here, the Kaplan-Meier median was about 27 years for the NIA control females versus the calorically restricted UW females were about 29 years. But if we come over to the Kaplan-Meier mean, what we find is the NIA old females lived about 28 years versus the 25 years for the calorically restricted UW females. And then for the NIA old control females under the Weibull median, we're seeing 29 years for them, and then for the UW calorically restricted females, we're seeing about 27 years. So for 2 out of these 3 statistics, the NIA old females, all control monkeys, actually lived longer than the calorically restricted UW monkeys. So again, a bit of a better diet. They're not eating ad libitum, and they're living longer as per the statistics. They have better survival curves as per the statistics than the calorically restricted UW monkeys, which it's very interesting observation. It does call into question it calls into question the diet rather than, just the caloric restricted aspect. Next thing we're going to look at is the monkey's weight. And what we're going to see with the UW monkeys is that the control monkeys are way fatter than the calorically restricted monkeys, which is going to be something that we're really not going to see with the NIA monkeys. So what they say here is UW calorically restricted females weighed significantly less, about 17 to 26% less than controls throughout the study period, and UW female controls weighed significantly more than the NIA juvenile adolescent female controls throughout. So the UW female controls weighed more than even the controls in the NIA study. The other thing they say is the difference between UW control and caloric restriction was slightly greater, with calorically restricted males weighing significantly less than controls. So what we're seeing here is, again, in the UW study, we're comparing ad libitum intake to caloric restriction. What you're seeing is the ad libitum intake on this terrible diet in the UW study led to, here we have the control group, and down here we have the calorically restricted group. On the left, we have weight in kilograms, and what we're seeing is that the monkeys, the control monkeys in blue, are significantly heavier than the calorically restricted monkeys in red. So I guess we can pick random data point, or basically what we're seeing is for males, the calorically restricted monkeys are about 10 kilos, and then the control monkeys that were fed a crap diet ad libitum were closer to like 15 kilos at some point, which is a pretty significant difference. And then for the UW females, what we're seeing there looks like they're sitting around 8 kilos, 7 to 8 kilos, whereas the control monkeys are sitting around 9 to 10 kilos or so. So a pretty significant difference in weight, especially when we're going to compare the NIA monkeys now. So for the NIA monkey weight, what we see is, in summary, for the NIA juvenile, adolescent, and old onset female cohorts, body weight for control and calorically restricted monkeys was not different from each other, and all were significantly lower than the UW controls. So even the control monkeys in the control monkeys in the NIA study was all weighed less than the UW monkeys. So the UW monkeys were just fatter overall. The other thing they say is, in summary, NIA juvenile and adolescent and UW male cohorts showed a clear body weight response to caloric restriction, but old onset NIA control and calorically restricted males were not different from each other and were significantly lower than the UW controls. So again, the NIA males, control and calorically restricted, were still weighed less than the UW monkeys. The UW monkeys were pretty fat. Again, they had a way worse diet. Now, what we're seeing here, well, I guess we'll start in the top of the females. In the juvenile and adolescent females, as we see, there's not a massive weight difference between the monkeys. The juvenile and adolescent females do weigh a bit more, but it looks like they weigh about a kilo more. The other thing you see here at the end of this graph is that the juvenile and adolescent females actually live to longer age as well. And again, the blue is the control groups and the red is the caloric restricted. I should have laid that out for you guys first. In the old females, what you're seeing, the control group, which is blue, and the calorically restricted group, which is red, they're about the same weights, with some minor differences at different time points, but they're pretty close in weight, or pretty, very minor differences overall. When we come down to the NIA juvenile and adolescent males, what we see for the control group is the control group is significantly heavier than the calorically restricted group. The caloric restriction group is in red here, and the control group is in blue. Now, something to keep in mind is that with this study, the control males actually outlived the calorically restricted animals pretty significantly. So they haven't completed the curves here, but this weight isn't necessarily. I mean, what I would guess here is, since they started restricting calories in these monkeys when they're young, they weren't able to reach a larger size. Probably smaller bone mass, decreased muscle mass, things along those lines. And again, they also didn't see a survival benefit in the juvenile and adolescent male and female monkeys here with caloric restriction. The control monkeys actually outperformed the caloric restriction monkeys in terms of survival curves, which is something that wasn't necessarily expected. Next thing we'll see here is in the NIA old males. So again, red is the calorically restricted animals and blue is the control animals. And we didn't see a massive survival benefit in the calorically restricted animals versus the control animals in the NIA old males either. And what you're seeing is the calorically restricted males actually weighed significantly less than the control males in later age, and then at about 25 years. So that's kind of old for the monkeys. And then before then, they were all roughly the same age. So, or roughly the same weight before 25 years with some minor variation. So that's also interesting. Perhaps with the decreased calories, the older males started to get maybe a bit cachexic or losing have some sarcopenia, lost some muscle mass. Whereas the control animals were able to maintain their weight because they were eating enough. So that's something that's interesting as well. I talked about this in the bioenergetic helpline a bit, where in older humans, having a higher protein intake is actually helpful to maintain lean mass and avoid sarcopenia and things along those lines. So perhaps that's something that's playing out with these NIA old males here. Next, we're going to look at weights of the NIA and UW females compared to the norm. So the norm here was established by this database. It's called the Internet Primate Aging Database. It's a repository of clinical and biometric data from healthy, non-experimental, captive, non-human primates housed at research facilities across the USA. So they used the data from over 1,200 individual rhesus monkeys of Indian origin. Mean body weights are calculated for the above age categories for males and females. So basically, they're taking captive monkeys that are healthy, not being used for any experimentation, and they're looking at what their average body weights are. And what you're seeing here, so this 0 here would be about like what that average is, and then we're seeing a change from the average in terms of percent difference. Now down here, what we'll see, and it gets a little confusing, but you have the these different colors designate the different groups from the study. So you have this heavy blue shade is the UW control monkeys, and we can see the UW control monkeys across the different age groups are significantly heavier than what normal monkeys are according to this primate aging database. So they're basically just super fat. Then when we come over here, we see UW calorically restricted. That's the dark red bar. What we're seeing is that the UW calorically restricted monkeys weigh less than the average monkeys according to this the average monkey weight according to this primate aging database. So I mean that makes sense, right? They're eating 30% less calories from baseline, so they should technically weigh less. Next thing we're seeing, these shaded graphs are the NIA juvenile adolescent control, the NIA old control, and then the NIA juvenile adolescent caloric restriction, and then the NIA old caloric restriction. Now, unfortunately, the only way you know the difference between which group is what is the direction that the lines are going here. Some are moving from are slanting from down from left to right, and others are slanting up from left to right. So basically, the only thing I wanted to show you is that both the control NIA monkeys and the calorically restricted NIA monkeys all weigh significantly less than the average monkey weight according to the primate aging database. Now, this database is pulling weights from monkeys that are captive and not being used in experiments in the USA. So you can assume that the diets of these captive monkeys are still garbage. They're still not that great. So in the calorically restricted monkeys and even the NIA control monkeys, their diet perhaps is a little bit better. So they're probably going to weigh less overall if we assume that the captive monkeys are probably on the fatter side. Again, there's a couple assumptions built in there. The general idea here is that with the NIA monkeys, they weigh less in general than the average monkeys, and they weigh significantly less than the UW controls. You can see with most of these bars that the dark red bars, the UW calorically restricted females, and then all the other shaded bars are the NIA control and restricted females, calorically restricted females. And what you're seeing is that most of these shaded bars are all lower than the UW calorically restricted animals. So even the control NIA animals still weigh less than the UW calorically restricted animals, which I think goes to show just how crappy the UW diet was in comparison. And again, even the NIA diet wasn't that great overall. So let's see for males. Same thing. The 0 is this average weight based on the primate aging database for these healthy monkeys that aren't being experimented on that are captive in the US. And then this left bar here is percent change from that baseline. And what you're seeing is the UW controls, which are this dark blue shaded, are all significantly fatter than the average monkey. And then you're seeing that the UW calorically restricted monkeys are all weigh less than your average healthy monkey. And then the next thing we're seeing is the NIA juvenile controls here way less than the average monkey. So they started, even the control group actually, which is quite interesting. So the control group actually weighed less overall in the NIA study. And then what we're seeing is in the NIA old, what's this? So the juvenile adolescent cohort, it looks like the juvenile adolescent control cohort weighed a little bit less as they got a little older, less than 5% it seems, than the average monkey, whereas the all of the calorically restricted NIA monkeys and then the old monkeys all weighed, even the control old monkeys in the NIA study all weighed significantly less than your average healthy monkey. So in general, the NIA monkeys, both control and calorically restricted, had less body weight than the average healthy monkey that's captive in the U.S. And whereas the UW control monkeys were all, for males and females, were significantly fatter than your average monkey, and the UW calorically restricted monkeys did weigh less. So you're seeing, I think you're seeing how this diet's playing out is in terms of the UW diet just being really terrible compared to the NIA diet, and that explaining a lot of these differences. Next thing we're going to look at here is adiposity. So we're looking at the UW monkeys' adiposity. The quote here, a main effective diet was detected for the NIA juvenile adolescent males and for both males and females from the UW study, where caloric restriction was associated with significantly lower adiposity. So calorically restricted monkeys had lower adiposity. The graph shows that here. So the UW females, looks like their body fat percent was between 10 and maybe 15 or maybe a little bit over 15. Whereas the control females for UW, their body fat percentage here in blue was sitting at a minimum of 15 and shooting almost all the way up to 30%. And then when we come down here for the UW males, the calorically restricted males, it looks like they are between 10 and 25% in later age, whereas the control monkeys are sitting around 20 to 30% over their lifespan. So the UW control monkeys were significantly fatter than the calorically restricted monkeys, and they also had larger weight overall. So it looks like a large portion of the weight in the control monkeys from the UW study was from fat tissue. Not surprising considering the diet. With the NIA monkeys, we're going to see something a little bit different. So they say the NIA juvenile and adolescent control and calorically restricted females did not differ from each other in adiposity, and neither of the NIA old onset monkey groups had a main effective caloric restriction on adiposity. So what we're really seeing here is that in the NIA monkeys, the control and calorically restricted groups didn't have massive differences in body fat percentage. And you can see that play out in these graphs, right? So for the females, what we're seeing, the red boxes and the blue boxes are on par with each other. They're pretty similar. And then what we're seeing over here, so this is for juvenile females. The other thing you'll see is that the control monkeys for juvenile females, that there's a cutoff here. So the control monkeys continue, whereas the calorically restricted monkeys stop. And I think that's related to the fact that a lot of the calorically restricted juvenile adolescent females died before the control juvenile adolescent females, because the caloric restriction had a negative effect on survival in the juvenile adolescent monkeys. When we come over here to the old NIA females, what we're seeing is not so much difference. It looks like, they're kind of intermingled in terms of their adiposity, their body fat percentage. When we come over to males, we see that the control males do have a bit more body fat percentage than the calorically restricted males, but the difference isn't as massive as what we saw in the UW monkeys. And then for the NIA old males, we're seeing that the calorically restricted monkeys had, it looks like a pretty decent amount less body fat percentage than the control males, but they also had significantly, they weren't as significant as the UW monkeys, which if we go back here, we'll see like this huge gap in terms of adiposity. So pretty significant levels. We're not seeing any of the NIA monkeys reach up really into the 30% body fat percentage, like we saw with the UW monkeys, except for some of these juvenile adolescent females in the NIA group. at around the 25, 26 years age, we're seeing them peak up to the 30%. But through most of the curve, it looks like they have less, and then they're actually dropping down later on. Whereas with the UW, we're seeing them, they're pretty close to sitting around that 30 mark consistently, or the high 20s. Next thing we see is the UW monkey blood glucose. So what we're looking at is changes in blood glucose across the lifespan here. And what they say is for UW monkeys, the control males had higher fasting glucose levels than the calorically restricted males from 15 years of age, with a further divergence of the curves after 23 years of age. While a noticeable difference was difference between control and calorically restricted females emerged only after 21 years of age. So here on the left, we see the UW males. This is blood glucose on the left side. This is their age on the bottom. The blue is the control and the red is the calorically restricted. And what we see is that the blue line starts to diverge from the red line around 15 years of age. And then at about 23 years of age, you start to see this line really diverge. So in the UW study, the males not only had more body weight and were fatter, they also had less ability to tolerate or ability to manage their blood glucose starting at about 15 years of age than the calorically restricted monkeys. Again, the UW diet was the really terrible diet. It was like the 45% sucrose diet with corn oil and soy oil, etc. In the UW females, we don't see the blood glucose values start to diverge until about 20 years of age. So it looks like the females were protected a bit more than the males. And we're seeing at about 20 years of age, this line starts to diverge. So again, we're still seeing worse handling in the control, the ad libitum fed UW female monkeys and male monkeys. For NIA, what they say here is for the NIA blood glucose, the NIA juvenile adolescent fasting glucose levels were equivalent for controls and caloric restriction up to 23 years of age, after which the control and calorically restricted males, but not females, began to diverge. Both control and calorically restricted females showed an age-related increase in fasting glucose after 21 years of age. For the NIA old onset cohorts, fasting glucose was consistently low for the duration of this study. So same thing here, blood glucose is on the left axis. On the bottom axis, the y-axis, we're seeing age in years. And what essentially we're seeing for the NIA juvenile adolescent males, the blood glucose stays pretty consistently the same between the control and calorically restricted groups up until 23 years of age. So we're not seeing that divergence that we saw for the UW at 15. We're seeing that occur at 23, so much later on. For the NIA juvenile adolescent females versus the control versus calorically restricted females, we're seeing that divergence occur about 21 years of age, and then we're not seeing any more survival curves or values or blood glucose values for the NIA juvenile adolescent females after about this 22, 23 age mark, whereas in the calorically restricted group, whereas in the control group, we're seeing values continue, so it looks like they reached a later age. Then what we're seeing here in the old NIA old males, calorically restricted versus control, we're not seeing any difference really across time. And then for the NIA old feed males, the control and calorically restricted, we're not seeing any massive differences across time. Things are pretty consistent, and they're both also on the lower side. So next thing we're going to look at is age-related conditions in the rhesus monkeys with the different groups. And we're going to start to talk about what was the benefit of caloric restriction with some of these things. So first things they say, veterinarians documented body condition and overall health of monkeys biannually at both study locations, and indicators of diseases or disorders identified. The age at which a monkey was first diagnosed with an age-related condition was used to generate morbidity curves. We'll see the figures in just a minute. Age-related conditions included sarcopenia, osteoporosis, arthritis, diverticulosis, cataracts, and persistent heart murmurs, in addition to age-related diseases including cancer, diabetes, and cardiovascular disease. So we're really going to talk about the cancer, diabetes, cardiovascular disease. There's not much data in this study about these other elements. So what we're seeing in the UW monkey's rate of age-related conditions, so the difference between the control group versus the calorically restricted group.
Cox proportional hazard regression modeling indicated that age-related conditions occurred at about 2.7 times the rate in control animals compared to calorically restricted animals for UW monkeys. So the UW monkey calorically restricted animals had 2.7 times less of these age-related conditions than the control animals. Now, again, their control animals were fed ad libitum. The calorically restricted animals were restricted about 30% of calories, and the diet for the UW monkeys was absolute garbage. It was pretty terrible. For the NIA monkeys, rate of age-related conditions, in the NIA juvenile adolescent cohort, age-related conditions occurred at twice the rate in control monkeys compared to calorically restricted monkeys. Again, the control monkeys appear to have better survival curves despite the increased rate of age-related conditions, which is interesting. The advanced age of the old onset NIA monkeys precluded detection of first occurrence of an age-related condition. So they couldn't look at the NIA old monkeys' first occurrence of these conditions, because when they got some of these monkeys, they probably already had some of these conditions because they were already older in general. So they couldn't look at those groups. So what we're going to see is the UW and NIA monkey cancer comparison. So on the left here, we have the UW monkeys, and we have on the bottom axis, we have the UW monkeys, and on the percent incidence of cancer, what we're seeing is the blue column here is control, the red column is calorically restricted. The control animals in the UW study, it looks like they had close to 50% incidence of cancer, whereas in the calorically restricted animals, it looks like they had about 25% incidence of cancer. So in the UW study, the calorically restricted monkeys had almost half as much cancer as the control monkeys. In the NIA study, what we're seeing on the blue column is control, red column is calorically restricted. The control monkeys had almost 40% incidence of cancer, whereas the calorically restricted monkeys in the NIA group had close to 30% rate of cancer. Now, again, the NIA control monkeys had better survival curves than the calorically restricted monkeys, despite the increased incidence of cancer. So just something interesting to keep in mind. While the NIA control group monkeys may have had higher incidence of these diseases, it seems like they have lived to longer age in general. I don't know if that was, I'd have to go back and look, but I don't know if they factored their older age in with these different things. Next, we're going to look at cardiovascular disease. We'll look at the UW first. Same thing, percent incidence on this left-hand side. On the bottom, the different studies. The control group in blue here, and the calorically restricted groups in red. The percent incidence of cardiovascular disease in the UW group was about 40% for the controls and about 30% for the calorically restricted. So about 10% difference between control and calorically restricted. Interestingly, in the NIA group, the control group had about 20% cardiovascular disease, whereas the calorically restricted group had about almost 30% cardiovascular disease. So if anything, the calorically restricted animals in the NIA group actually had more cardiovascular disease, which is quite interesting overall. Next thing we're going to look at is diabetes and insulin resistance. So in the NIA, same thing, percent incidence on the left, and then the different groups on the bottom. Now, the different studies looked at different factors. So the UW study looked specifically at insulin resistance for first occurrence, and then the NIA study looked specifically at diabetes. So we're not comparing apples to apples. We're like comparing apples to pears a bit here. What we're seeing in the NIA group is the control group had about 14% or so incidence of diabetes, and the calorically restricted group had about 10%. So the calorically restricted group had less diabetes in the NIA study. And in the UW study, there was close to 50% of the animals developed insulin resistance in the control group, and only about maybe 10% of the calorically restricted group developed insulin resistance. Something interesting to note here is the scale. So and again, it could be related to the fact that diabetes had a harder criteria to hit in the NIA study than just insulin resistance. But the NIA scale here is up to 15%, whereas the UW scale for insulin resistance is up to 60%. So just a kind of a drastic difference. Again, they had different cutoffs for what determined diabetes versus insulin resistance, which could account for this scale. Last thing here to discuss, and I kind of brought this up a little bit earlier, is we'll get into it. I'll just read the quote. So, in rodents, early onset caloric restriction is more effective in extending longevity than adult onset caloric restriction. For non-human primates, it appears that caloric restriction, while beneficial when implemented in adulthood, does not improve survival when implemented in juveniles. Furthermore, it appears that caloric restriction is not uniformly tolerated in young animals, whereas the NIA juvenile adolescent calorically restricted males and females reach 80% mortality earlier than controls. So 80% of the monkeys in the calorically restricted 80% of the monkeys in the calorically restricted groups, the juvenile adolescent groups, so they started caloric restriction when they were juvenile and adolescents, died before the control animals who weren't calorically restricted at all. So at least in rhesus monkeys, starting caloric restriction in juvenile and adolescent monkeys doesn't seem to be a good idea. Although in the older monkeys there wasn't really a survival benefit, but it looks like there is some degree of benefit in terms of some of the disease processes. Now, I just want to slide us all the way back here, and I want to put this into perspective again. The NIA diet was still garbage. It was, so even though we weren't seeing the benefits and whatnot, they were still eating soybean and fish meal, and then wheat, corn, sucrose, and then soy, corn, and fish oils with cellulose as a fiber. So still a pretty terrible diet as far as nutrient sources go, just significantly better than the UW, which the UW diet, we're looking at lactalbumin, and then corn, sucrose is 40% of the diet, dextrin, and then corn oil and cellulose. So there's multiple factors that we're looking at here if you're comparing these two studies just from a dietary perspective. You could talk about omega-3 to omega-6 ratio. You could talk about there are some beneficial compounds inside wheat and soy and corn in terms of like polyphenolic elements that could have possibly had a benefit. Looks like they had a greater fiber intake here, better vitamin intake here, better protein content in here. There was less sucrose in the diet, 6.8% versus 45%, which is insane. So overall, what you're really seeing here is the NIA probably didn't see as much of a benefit because the diet was better, and the comparison was between monkeys that weren't fed ad libitum, they just weren't calorically restricted, to monkeys that were calorically restricted. So it's a different comparison because in the UW you have like the absolute worst diet possible, and then it was comparing ad libitum to caloric restriction. So you're seeing benefits here, but you're not really seeing much of benefit over here. So the question really comes in is, if you had monkeys that were eating a normal diet, none of this garbage, would we assume then that caloric restriction would still have the benefit? So that's what would really be good to see. It's like overall, essentially what my interpretation of this is that if you feed monkeys less garbage, they will develop less disease. And in this case, they didn't actually live longer overall, but they may develop less disease. And over here is if you feed monkeys a ton of crap as much as they want, they'll get more disease and they'll die sooner. So that's essentially what we're seeing here. It's hard to say if the benefit was just caloric restriction itself versus elimination of or having less of all of this garbage. And again, the NIA study isn't showing improved survival outcomes, particularly for juvenile adolescent monkeys. They're just showing improved disease there are less disease or less percent incidence of disease inside the calorically restricted monkeys, which if this diet was fruit, flowers, leaves, seeds, gums, buds, clovers, roots, bark, and then some insects, bird eggs, fish, and shellfish, I think we'd be seeing a drastically different outcome in the studies between the calorically restricted and not ad libitum fed monkeys, like normally fed monkeys. So that's what I wanted to talk about today. I wanted to break down some of these caloric restricted elements. I wanted to really pull out the context in which these studies have been created, so we can see that what that there may be other reasons for the benefit that we're seeing besides just this like austerity measure of drastically decreasing your calories. And then there's also some elements. I did have some studies that were discussing this. There are some problems with caloric restriction in terms of bone mass, muscle mass, hormonal function, for particularly for women, maintaining adequate body fat to be able to have a cycle and things along those lines. That could be possibly problematic in the long run. So if you're not getting a survival benefit, and the benefit of the caloric restriction in these studies is largely related to monkeys eating less garbage, then the solution here, it would make sense to not necessarily calorically restrict, but to just eat quality foods. If this diet was fruit and tolerated vegetables and plant components and then some insects and fish, and the monkeys weren't like massively overeating, they were eating a normal amount versus monkeys that had basically were starved to some extent, I would wonder if the regularly eating monkeys on a normal healthy diet would perform better than the calorically restricted monkeys. So that's my take here. Wanted to provide you guys with some context on some of this caloric restriction stuff. There are some human studies on caloric restriction, so I'll get into some of those. We can break some of those down in the future. And yeah, so keep an eye out for those. We saw some elements in rats, and we're also seeing some elements inside monkeys. Stay tuned for the next one, guys. Thanks for following all the way through. Take it easy.